Now sometimes we have what's called a piecewise defined function. A piecewise function just means I have different equations depending on what x is equal to. And so depending on which direction I'm coming from, I might use the top equation, I might use the bottom equation, and so I just look at my question here. First of all, I'm finding the limit of my function as x approaches -2 from the negative direction. So in other words, I'm going to use the values that are less than -2. If I'm approaching from the negative direction, then I'm using the less than ones, right? So I am going to use this expression up here, and so I'm going to put -2 in for my x's. So I'd have minus a -2 squared minus 3 times -2 minus 1. So -2 squared would be 4. It has the minus sign in front, so -4 plus 6 minus 1. That would be minus 5 plus 6, which gives me 1 as I approach from the negative direction. If I do part B, as I approach -2 from the positive direction, in other words, I'm greater than, I wrote a less than, in other words, I'm coming towards -2, so I want the ones that are greater than -2 because I'm coming from the positive side, so the number's bigger than -2. So in this case, I'm going to use this function, so I would say -2 plus 1 squared. Well, a -2 plus 1 is -1. A -1 squared is a positive 1. Since both of these two numbers are the same thing, as I approach from both the negative direction and the positive direction, I approach 1. Therefore, my limit as x approaches -2 is a positive 1. If these two numbers are not the same, then my limit would not exist. So on number 11, this one, I have one with an absolute value in there, and so I have to think about my rules for absolute value. And so this is one where if I would put the -2 in there, I would get a 0. So I want to think about if I approached from the positive direction. So if I have a -2 and I'm approaching it from the positive direction, I might use -1.999. Something really close to -2. Here, if I have -2 and I'm approaching from the negative direction, I might use -2.001. Remember problems 1, 2, 3 where we had to plug the numbers in and see what it approached? This is one because when I put the -2 in there, I get 0, is when I would have to put values in and evaluate those values. So if I think about this one, -1.999 plus 2, and the absolute value of -1.999 plus 2. I put my calculator somewhere. Must be over there. Now this one works on this one because you notice you have the exact same expression on the top and on the bottom. It's just one has the absolute value and the other doesn't. If this was a +3 and that was a +4, I may have to do it a little bit differently. But because it's the exact same thing, and normally I would have this over itself as 1, I've got to do it just slightly differently. So if I have -1.999 plus 2, I would get a positive 0.001. If I have -1.999 plus 2 again, I get 0.001. Since this is positive and it's in the absolute value, it's going to stay positive. And then anything divided by itself is going to stay positive 1. Now if we look at the second part of that, if I use -2.001 plus 2, and then the absolute value of -2.001 plus 2, this would give me -0.001. This would give me -0.001, but I have to do the absolute value. And when I do the absolute value, it's going to be a positive. So I have a negative over a positive, which means that one's going to approach a negative 1. If you look at the Alex explanation, they're not going to put numbers in there. They're just going to say, oh, well, if this one's positive, then I'm going to get a positive over a positive, and it's going to be positive. Here, if this is coming from the negative, I'm going to get a negative on top, but a positive on the bottom, and I'm going to get a negative. Well, I like to use numbers. They make more sense, so I pick numbers that make sense and plug them in. Because in this case, this is positive 1 and this is negative 1, the limit here does not exist because they don't approach the same value as I approach from the positive direction and the negative direction. Number 12, we're back to a piecewise one where we have to evaluate this. Here, if x does not equal 3, I would use this equation. The only time I'm going to use this equation is if x equals 3. So again, if I think about this, as I approach 3 from the negative direction, I would use 2.999. That's not exactly equal to 3, so I would use this function, but I'm going to use it with a 3 in there since x is approaching 3. Same thing here on this one. If I were thinking about approaching from the positive direction, I'd use 3.001, but again, that's not exactly equal to 3. So for both of these, even though the limit is approaching 3 from the negative and the positive direction, I'm going to use this top equation. However, when I use that top equation, I'm using the 3 that I'm approaching. So I'm going to have negative 3 squared plus 3 times 3 plus 3, which gives me negative 9 plus 9 plus 3, which happens to be 3. I'm using the exact same equation for this one, so I'm going to get the exact same answer. So the limit as x approaches 3 is going to be 3 because I get the same answer for both of them. So what would be happening on this graph is you would have something like this where it's going to 3 and going to 3, and then the 5 has a filled in dot. So even though here at exactly x equals 3, I'm at 5, my limit as I approach 3 is 3. So it's not always true that the limit is the same thing as the point where this is exactly equal to this. It's kind of strange, I know. So that's why they give the definition of the limit as you approach that value. Do they both approach the same number? Not necessarily what is it when it's exactly equal to that value. So as I approach negative 3, I'm still not exactly equal to 3. I use that equation. As I approach 3 from the positive direction, I'm not exactly equal to 3. I use this equation. And so I still use the 3 when I substitute it in. That's just telling me which equation to use. My limit then is going to be 3, even though at x equals 3, I have a 5. It's kind of weird.